Okay, so we're familiar with the concept of plotting related variables on graphs. And the type of graph that you use to do this is a scatter plot, which will show you the y position versus the x position of some given data. Okay, so for instance, we have some substance here, we have some data for some substance here, and we say, okay, so as we increase the volume of substance, okay, as we add more, say, liquid into this container, and we've placed it on a scale, we will find that the value on the scale will increase, right? Will increase. So more volume equals more weight on the scale. That makes sense, right? But what we can't really see is how exactly that data relates. We would predict that it's probably linearly. If we double the amount of liquid, we should double the weight. If we triple the amount of liquid, we should triple the weight. That's our expectation. We have to make a graph, however, in order to sort of visualize this data. So we're going to use software to do that. We'll use Excel to just see how these things relate. Okay, so we're going to use Excel to kind of just quickly analyze the data that we're given. So make two categories, go weight and volume. Now, what Excel will do is it's going to take this to be the value on the x-axis, which we know to be the independent variable. So this will be the independent variable, and this will be the dependent variable. Okay. Depending on how we want to look at this data, I think in this case it might make more sense to actually put volume here and weight here. Okay. So let's just flip it around, because what we want to do is we want to change volume, right, and see what happens to weight in relation to that volume. Okay. So now let's start putting our data in. Okay, so these are the points that you're given. And then their corresponding weights. Weights given in terms of newtons and volumes given in terms of milliliters. We'll just pause there. So we've essentially just made a data table. All right, so here's your numbers. Volume in milliliters, corresponding weight in newtons. So what we'll do is we'll highlight our data here, and Excel is set to look at this as the x value, or the independent variable, and this is the y, the dependent variable, and that's exactly how we want to do this. Then we're going to go insert, and we're going to look at our chart options. We're going to choose the chart option that looks like a bunch of little dots. That's our scatter plot. We want a scatter plot with no line put on it. Okay, so there's our data points, and you'll notice the rest of the chart is pretty much blank. Okay, so once you have that, it's nice to keep track of what you're actually talking about. So let's put a title here. So for chart title, it's always going to be your dependent variables versus your independent variables. So your dependent variable here, again, is the weight. Okay, we want weight versus volume. Okay, so the weight is what's changing. The volume is what we are controlling. We're adding volume and seeing what happens to the weight. Okay, and it's also nice to have some titles on your axes. So if you press this little plus thing, you can add elements. I want to add axes titles just to keep track of what I'm talking about. Okay, so here we have weight in the unit newtons, and here we have volume in the unit milliliters. So volume in milliliters, of course, looks funny. Let's fix that. Perfect. Okay, cool. Now, clearly this is linear, all right? We have no problem seeing that this is a linear line. But something we want to do is we want to add a trend line in here. Okay, so we're going to add a trend line, and it's a linear trend line, and we also want to set an intercept at 0 Okay, so the line will come through 0. If there's no volume, there's no weight. We're smart enough to know that. Okay, apparently it does not want to extend my line back through 0 for me. Not sure why, but that's okay. I can actually probably just add a 0, 0 onto here to make that happen. Okay, so now we're back in here, and what we want to do is now analyze this relationship. Okay, so what we need to do is we need to find the slope of this line, and we need to write a y equals mx plus b relationship telling us what our weight will be with relation to our volume. All right, so since we can see this is a linear line, we can do our slope directly from our chart. You don't have to read it off the graph or do anything weird. So what we want to do is we want to find the equation for weight with respect to volume. So weight for a given volume. All right, so first things first, let's find a slope. So we can use the entire thing, right? Because the slope never changes. We can just grab, you know, a run and a rise off of here. So let's move this over. Okay, and we can put in some values. So down here we've got a 0 value, and up here in terms of our y, we have a 15.6 value, right? Remember our weights on this column, so this is our delta w if you want, or delta y if you're speaking generally. In this case it's weight. And here we have our delta x, or really it's delta volume, okay, in this direction. So what is our delta volume? Well, it's 42.1 at its max. 42.1, and down here it's 0. So slope then, m, will be rise over run. So delta w, change in weight, for a given delta x, change in volume. So our weight then is 15.6 minus 0. Our volume is 42.1 minus 0. And that's because I added a 0, 0 to here, right? You could just as easily use 42 and 9.9 and 15.6 and 3.7. But we'll use this because it's what we have now. So you solve for the slope and you get 0.37, and we need to know what our units are. So that's newtons per milliliter. So newtons per milliliter. So newtons per milliliter. All right. So we gain about 0.37 newtons for every milliliter we add. And now we can write our equation, right? So this is a linear line. It's y equals mx plus b, okay? Our y, however, is going to be weight. The weight we would expect is equal to 0.37, that's our m value, the slope of the line, times whatever volume we have, so times v, plus 0. 0, 0 is our intercept. When we have 0 volume, we have 0 mass. Okay, so we've just written an equation of the y equals mx plus b form to now find what the weight would be for any volume that you can think of. Okay, so punch any volume value you have here in terms of milliliters. It can be larger than the chart, and you'll come up with the correct weight for that particular volume of substance. So the nice thing here, the interesting thing is, you know, you can run a few experiments, 4 or 5 experiments, change your variables or get 4 or 5 data points, and then if you decide that that's enough to establish a strong relationship, you can then from that write essentially what becomes more or less sort of like, if you want, a little scientific law about this particular relationship. I think the general law, maybe this is more like a model. The general law would be, as I add more volume, whatever I have is going to get heavier, okay? Just a couple of little rules about how much data is enough to establish whether or not you have a relationship. One, it should cover one order of magnitude in your independent variable. Okay, so you should have at least one order of magnitude. I mean, I do here because I started at 0, but even my first one goes from 10 to actually 42. So that's not even a full order of magnitude. I should really try to go get something down here around 4, so I get that one order of magnitude of spread. That's kind of just a rule of thumb. 2 is you want usually at least 5 data points. And 3, you want a sufficient spread between them. You want a sufficient range. So you don't just want them all like, you know, right down here, right? You want them spread across your whole order of magnitude, okay? So let's move on. Here's some new data. This is talking about radius versus the area. So clearly I think we're talking about a circle here. What happens to the area as you increase? So we'll take this data and we'll pop it into Excel, and we'll just see what we get when we graph it. All right, so here we are. We've entered our data. Now let's work with it. So highlight it again as we did before. Insert, grab the scatter plot, and we can see that we have a non-linear relationship now. Okay, so here's all our data points, and they seem to be following a curve. So I'm just going to doctor up this chart to make it a little more easy to see, and then we'll add a trend line. Okay, so there, that's laid out and labeled. Oh, and I just realized I didn't put my units, so let me do that. There we go. I'm going to click on one of these dots, double click it, and it didn't work. There we go. I'm going to right click it. I'm going to say add trend line. Well, this is not a linear trend line. That doesn't work. So we're going to have to go through and find one that does. And it looks like it's a power trend line. Okay. So there we go. We can see this curved line here, this curved relationship. So we cannot directly do a y equals mx plus b with what we have here. I'm going to show you what you need to do. So when we see a relationship like this, okay, we see a curve like this, it's some sort of exponential relationship, right? If the curve is going up like this, it's exponential. It could be a squared relationship, and it could be a cubed relationship, or so on up the pipe. So what we're going to do is we're going to try to straighten this graph. So we're going to take our data in the x column, and we're going to try to square it all. And we're going to see what happens to this graph when we do that. Okay, so I just want to keep a hold of all my data. So what I'll do here is I'll grab it all, and I'll just move it down here, and we'll work with it over here. Okay. So now remember, instead of having just the radius here, I want to make a column that has the square of the radius. Okay, so I want radius to the square versus area. All right, so I can just copy. This is the nice thing I can do in Excel. I can copy this column. Oops, do that. Control C is copy. Control V is paste, and paste that data down there. But now what I want to do is I want to find the square of each of these values. And there's a nice quick way you can do this. You can write a little formula in Excel to square those values. So follow along. We hit the equals button. Okay, you'll see it comes up here, the equals button. That means that Excel is going to now expect you to punch in a little formula to do what you want to do. Then you're going to put a bracket. Then you're going to click the cell you want to apply the formula to. In this case, it's A52. I can actually type that right in, or I could just click here. Either way works. Oops. No, I made it mad. Sorry, we're good. Okay, A52. So you can just click that box. And then what I want to do is I want to square that. So square symbol is the little hat to the 2. Then you close the brackets and you hit enter. And look at that. It squared it for you. Okay? It squared it for you. If I click here, you'll note that although it's showing 0.36, if you look up here, the formula I have is whatever's in A52 squared. Okay? Now here's the magic. Hold Shift, click all the way down, and press Control D. That's fill down. that copies this formula, but it iterates it. A53, A54, and so on. So essentially, really quickly, what I did there was I squared all these values. All right, without having to actually go with my calculator and square them, I can use the spreadsheet to do it for me. Now what I'll do is I'll reinsert a new scatter plot with my squared data. And lo and behold, look what happened. It made a straight line. Okay, I now have a straight line, and once I have a straight line, I can work with this. So let's do our titles so we know what we're talking about. Okay. This is now area versus radius squared. Okay, so it's area versus the square of the radius. If you have questions, I'll get to them in just a second here. Okay, on the bottom, we have radius squared, and on the side, we have area. Okay, this is in meters. Okay, this will now be in meters squared as well. Okay, but hang on. Get rid of that. And we'll also just pop our trend line in there, which we'll now see is going to be a linear trend line. Okay, so now we have a straight line. Now we can apply y equals mx plus b. Okay, so now we have a straight line, we can do y equals. So we're going to go find equation for your straightened line. Just remember though, the x is actually now x squared. Okay, so what this will be then is it'll be y equals m x squared, right? Since we squared this, plus a b value. Okay, so first things first, let's find m. So m in this case, of course, is going to be rise over run, or it'll be delta y over delta x. And we see here that we will intercept 0, so that's nice. So y in this case is area, so it's 172 minus 0. X in this case, our radius is 54.76 minus 0, and let's find that value. So this value that I get here is 3.141. And so what that does then is it leads us to now write this out in its correct form. Y, which is area, right? Y equals mx plus b. Area equals m, 3.141 times my x value. Well, my x value is actually the square of radius, r squared, plus an intercept of 0. Aha! The area is equal to pi r squared. So we can come up with a mathematical formula by taking data from experiments, right? Cut out a bunch of circles, measure their areas, and you will come up with that the relationship between the radius and the area is the square times pi. The square of the radius times pi, right? 3.141 is pi. Here is a y equals mx plus b. But because we had to square the radius in order to straighten the line, when we plug in our x value, we just plug it in as whatever it is that we've done to it to get the straight line. Okay? This works for everything. It could work for cubes. It could work for square roots and so on. Tomorrow, we'll look at different graph shapes and how to solve for them.